In this video, we are going to talk about cone surface area and volume, the first part. And so this is going to cover just the surface area of a cone. Okay, the first thing that we want to review is a sector, okay? So remember, the sector of a circle is part of the area of a circle. So this green area right here. It's formed by an arc on the circle and two radii of the circle that intersect at the endpoints of the arc. So remember, the arc is this point right here, AC, and then there's two radii, okay, which is just the plural form of radius because there's two of them, and that forms the whole sector. So this whole green area is the sector. Now, the reason that that's important to know the sector is because when we talk about the net of a cone, okay, parts of a cone is made up of a sector of a circle and then a circle. So if you were to draw the net of a cone, it would look like this. It would be like a sector, and then that's supposed to be a circle there at the bottom. And then it would be have a circle there at the bottom. Okay, so that's what the net, although it would look prettier if you found it somewhere else, that's what the net would look like. So, so when we're talking about parts of a cone are actually very similar to cylinders, and they're very similar to pyramids. Okay, in the pyramid, as far as relating it to the pyramid, a cone has a lateral surface area and they converge at one point called the vertex, just like a pyramid, and they sit on just one circular base. Okay, now remember, pyramids sit on square, rectangular, or triangular bases. So a cone sits on a circular base, but the lateral edges and the lateral surface converges up to one point called the vertex. That's at the top here. Okay. Is also similar to a pyramid in that it has two different heights. It has the slant height and then it has the altitude. Okay, the slant height is the height from the vertex to the edge of the base. Okay, so that would be this line right here, or this line right here. The altitude is the line that goes perpendicular from the vertex and it's perpendicular to the base. Okay, so for example, in a right cone, the altitude is right in the middle of the base. Okay, if you have an oblique cone, right, see how it's slanted over here, then the altitude is going to be outside, but it's still going to be perpendicular to the base. Okay, it's just not going to be in the center of the base. Okay, also another way that it's like cylinders is that it has an axis. All right, we call the axis is the line that connects the middle of the base to the vertex. Okay, so in a right cone, the axis is also called the altitude. Okay, if you were to have an axis on this cone, it's not drawn, it would be like this. So it would go from the center of the cone up to the vertex. So let's label this one right here. We want to label the altitude, the slant height, the radius, and the axis. Okay. So the altitude, remember the altitude is at the vertex and it's perpendicular to the base. Okay, so the only line here that's at the vertex and is perpendicular to the base is line AD. So that's your altitude. Your slant height, okay, it's the height that you measure from the vertex to an edge of the circle. So in this case, our slant height would be AC. Okay, and then the radius is just the radius of the base of the circle, so that would be CB. And then the axis is the line that goes from the middle of the base to the vertex, so that would be AB. Okay, so to find the surface area of a cylinder, we're going to use the formula pi RL plus pi R squared. Now these letters should be familiar to you. R, right, you know that R stands for radius, so that's talking about the base, right? In this case it would be 8. L, we've seen L when we talk about pyramids. L stands for the slant height. So in this case, it would be 14 centimeters. Okay, if you were just going to find the lateral surface area, okay, then you're going to use pi RL. Just like the other formulas where we talked about where it was the first, right? Like pH is finding the lateral surface area, right? So in this one, finding the lateral surface area is just pi RL. Okay, and then pi r squared represents the area of the base, right? And think about it, the base is a circle, right? The area of a circle is pi r squared. Okay, so here we want to give the exact answer in terms of pi and the approximate answer using 3.14 for pi. Okay, so we have surface area equals pi RL plus pi r squared. Okay, sorry. Okay, so here we have pi, r is our radius. Okay, so here we have a diameter, right? It's 48. So we're just going to take half of 48, which is 24. Okay, L is the slant height. That's the height from the vertex to the corner. So that would be 30 meters. And then we have pi r squared. Now we already found r, that was 24, and then squared. Okay, so now we're just going to finish this out. We're going to take 24 times 30, which is 720 pi, plus 24 squared is 576 pi. And now we're going to add those together, 576 and 720, which is 1,296 pi meters squared. Okay, so that would be the exact answer in terms of pi. The approximate answer then, we would take 1,296 and times it by 3.14, which would give us 4,069.44 meters squared. Okay, so those are our two answers. This first one is exact. The second one is approximate. Okay, so here, same thing. Give the exact answer in terms of pi and the approximate answer. So pi RL plus pi r squared. So our radius here, it gives us the radius already. It's 9. L is our slant height. Okay, so slant, remember vertex to the edge of the base. So that's 15 plus pi r squared. So we have pi 9 squared. So now we're going to take 15 times 9, and that's going to give us 135 pi. 9 squared is 81, so we have 81 pi. So we're going to add 135 and 81, which is going to give us 216 pi centimeters squared. So that's our exact answer. And then our approximate answer, then we would take 216 times 3.14, which would give us 678.24 centimeters squared. Okay, so last one, exact terms and answers of pi and approximate using 3.14. Okay, so now if we look here, okay, we have pi RL plus pi r squared. So we have pi, okay, our radius, they're given a diameter, okay, so half of that, right, would be 6. So we're going to put 6 in here for the radius. L is going to be the slant height. Now if we look here, they haven't given us the slant height, have they? Now, what they have given us is the altitude, right? We see that that's 8. So if we look right here, what do we know? The altitude is perpendicular, right? So we know that this is a right triangle, and this is the hypotenuse. So since we know the radius and the height, then we can use Pythagorean theorem. A squared plus b squared equals c squared. So we can say 6 squared plus 8 squared equals c squared. 6 times 6 is 36. 8 times 8 is 64. And then we're going to add those two together. Take the square root, and we're going to get c equals 10. Okay, now, if you had noticed, okay, remember earlier in the year we talked about knowing our triangles, and we had a 3, 4, 5 triangle. That was one that we were told to memorize, okay? Now, if we look right here, okay, all we did right here is just take these times 2, right? 6 and 8 are just 3 times 2. 3 times 2 is 6. 4 times 2 is 8. So since we know we did multiple of 2, all we had to know there was take 5 times 2 times, which it was 10. Okay, now Pythagorean theorem is always a good way, if you forget that, but that would have been a quicker way to do it. So our slant height now is 10. And then pi r squared is going to be pi 6 squared. So now we have 10 times 6, which is 60 pi, and then 6 times 6, which is 36 pi. Then 60 plus 36 is 96 pi centimeters squared. Okay, so that's our that's our exact answer in terms of pi. And then we're going to take our approximate answer. So we're going to take 96 times 3.14, and that's going to give us 301.44 centimeters squared. Excuse me, that's approximate. So those are our two answers. And that is the end of cone surface area and volume part 1.